Hello, I'm David Dahl, and I would like to share a short presentation that I have developed regarding almond pollination and fertilization. Now let's start with some basics. Almond flowers are perfect, complete flowers. Perfect means that they contain both the male and female parts. Complete means they contain all four parts of a flower, including the male and female parts, plus the petals and sepals. The male parts are the stamen, which is made up of both the anther and filament, and pollen is borne on the anther. The female parts are made up of the pistil, which is comprised of the stigma, style, and the ovary. The ovules reside within the ovary, and after fertilization will develop into the seed, or what we know as the almond kernel. Before we discuss pollination, we have to talk about pollen incompatibility. Pollen incompatibility is a mechanism evolved by plants to ensure genetic outcrossing. Almonds have evolved this process to increase genetic diversity, and most California softshell varieties require outcrossing in order to set a nut. This is why we plant multiple varieties within the same orchard. The mechanism of pollen incompatibility within almonds are known. An almond pollen containing the same S allele as the pistil will not be able to fertilize the ovary. These pollen grains begin to develop, but fail to grow through the style. The first scenario in the image provided by the Almond Board of Australia demonstrates this. Pollen grains containing different S alleles are able to grow through the style, eventually reaching the ovary, fertilizing the ovule. Pollinating varieties should be selected based on their pollen groups, and pollen groups are based on their S allele. Multiple varieties with different S alleles and good bloom overlap are ideal for almond orchards. This is represented by both the middle and the last figure within the drawing. Since almond pollen is sticky and heavier than most other plants, wind pollination is not very effective. As such, pollinators, which are often honeybees, are required to move pollen from one variety to the other. Within most European varieties, however, outcrossing is not required due to the breeding of self-fertile varieties. Within these varieties, pollen from the same tree and variety as the flower can fertilize the ovule. This allows the ability to plant solid blocks of a single variety. It is important to note that some selections within the U.S. are also self-fertile, which include Independence and Shasta. Even though these varieties are self-fertile, pollinators have been shown to increase yield, ranging from 5 to 20% dependent upon the cultivar. Now on to pollination. First and foremost, pollination is a process. This is due to the large number of flowers on an almond tree, which can be as high as 30,000. These flowers open over a period of 7 to 15 days. The rate of opening is dependent on the weather. Warmer conditions increase the rate of flower opening, which is also known as anthesis, while colder temperatures will delay the progression of bloom. Having pollinators active during the entire process of pollination is required to maximize nut set. After anthesis, pollen shedding begins within a few hours. Anther dehiscence occurs during the daytime in the temperature range of 18 to 26 degrees Celsius. Rain and cold temperatures will delay dehiscence. This is essentially a self-regulating mechanism that has been evolved by the almond tree to reduce the damage to the pollen caused by these conditions. Once the pollen gland lands on the stigma, the pollen tube begins to grow. This is where the dance begins. The stigma is only receptive for 3 to 4 days within favorable weather. Hot or cold temperatures can damage the stigma, reducing receptivity. Pollen grains on the stigma will stick due to a sticky substance produced by the stigma. After a few hours, the pollen grain will germinate and begin to grow through the style. If containing the same S allele as the style, the pollen grain will die. If differing alleles, the pollen tube begins the race to the ovary. It will take 2 to 4 days for the pollen tube to reach the ovary, ending its journey at the embryo sac. Interestingly, ovary maturity and receptivity is stimulated by the growth of the pollen tube through the style. After initial pollen germination, the ovary and ovules are receptive for 4 to 5 days, with declining fertility as it ages. Once the pollen grain reaches the embryo sac, the pollen grain releases its germ cells. These will fertilize the two ovules. Typically, one ovule outgrows the other, leading to the abortion of the other ovule. If this does not occur, a double kernel will form, impacting kernel quality at harvest. Occasionally, the ovule may divide after fertilization, forming a double nut. Again, this also reduces kernel quality. Both of these traits are typically dependent on the variety and may be influenced by weather conditions at the time of fertilization. The process of pollination and fertilization needs to happen as rapidly as possible. Due to the varying days of viability for the various organs, delays in pollination can lead to reductions in nut set. Studies have shown that pollination that occurs within 1 day of flower opening will lead to the greatest percentage of nut set at around 30%, while 1 to 2 day delay will lead to a net set of 21%, and 4 to 5 day delay will lead to less than 1% of the nut setting. As such, having active pollinators within the orchard is required to maximize nut set. Pollination is typically assisted by pollinators. Within almonds, most pollination services are done by honeybees. Honeybees are not the most efficient pollinators, but the great number of bees per hive outweigh the inefficiencies. There are roughly 10,000 to 15,000 bees per hive. Since bees tend to work flowers within a vector, they are not flying from flowers to flowers of different almond varieties. Rather, pollen mixing occurs at the hive, in which foraging bees then carry it back to the field to pollinate the flowers. Hive strength is critical for efficient pollination. This is because stronger hives have a greater number of bees acting as foragers. Within the figure, the y-axis shows the percent of the hive that is dedicated to the various tasks. Temperature in red, as well as tending to the brood, which is in yellow, and foraging bees are in blue. Along the x-axis is the number of frames within that hive that are filled with bees. As hive strength increases, the percentage of bees performing maintenance functions decreases, while the percentage of foragers increase. This, along with greater bee numbers, leads to a larger number of foraging bees. Typically with almonds, we recommend an average of 2 8-filled frames per hive per acre, which is 5 per hectare, for California almonds. This recommendation is based on the trade-off associated with the expense of higher population hives and the number of foragers present. Bee foraging is affected by weather conditions. Temperatures above 12 to 13 degrees Celsius are ideal with wind speeds less than 6.5 meters per second. Sunny days are better than cloudy days as they increase the warmth of the hive. Hours of the day that fit these conditions are defined as bee flight hours. These hours have been traditionally counted to help determine the quality of the pollination period. Beehive placement should take into account hive conditions. Placing hives in locations in which they receive morning sun can help increase forager activity. As such, avoid placing hives in shaded areas, west or the north side of the trees, or within orchard rows. Hives should be placed around the perimeter of the orchard in order to maximize bee coverage. Due to the ongoing concerns about honeybees, there has been a lot of interest in looking at alternative pollinators and pollination methods. Bumblebees and other native insects have been shown to be effective pollinators. Bumblebees, in particular, are active at lower temperatures and higher wind speeds. When placed amongst honeybees, they increase the rate of pollination due to resource competition. As such, placement of bumblebees may improve the rate of pollination within bad weather years. Unfortunately, however, research suggests that the number of bumblebees within colonies tend to be too small to ensure adequate pollination for California almond varieties, and research still needs to be done to determine the number of bumblebees required. Other natural pollinators, such as wasps and bees, are also been shown to be effective pollinators. These insects typically don't emerge in time for almond pollination and often need human intervention, as in the case of blue orchard bees, to be successful. Artificial pollination methods, meaning pollination by machines, seems to be a logical process to evaluate. Efforts within this field have occurred over the past several decades. It requires collecting pollen from a compatible variety and applying it to the tree by some type of sprayer. Research has shown that there's an increase in nut set when compared to no honeybees, also known as the negative control, but it does not perform better than when honeybees are present, also known as the positive control. This is most likely due to the number of flowers opening over a period of days, which is staggering receptivity, leading to the reduced effect of a single application. Multiple pollen applications may be more effective, but may not be economical. Although methods are improving, it is still strongly recommended to utilize pollination services unless beehive prices are too high or are unavailable. Please note that most of the studies within pollination and pollinators have been conducted within US or California varieties. As such, self-pollinating or self-fertilized varieties are an exception to the above comments. With these varieties, bumblebees may be a suitable alternative, but again, this still needs to be researched. Thank you for taking the time to listen to this presentation on almond pollination and fertilization. If you have any questions, thoughts, or comments, please leave them below.